In this video, I'm going to solve the second question, which is question number 52 from chapter 27, circuits. So I'm going to solve this question. In figure, what value must R have if the current in the circuits is to be 1.5 milliampere? So you have to see the circuit diagram. So in this circuit diagram, we have 1.5 milliampere of current, and also we have two EMF, which is EMF 1 and EMF 2. So this is your EMF 1 and EMF 2. And if you see this circuit diagram, we have one external resistance R, caps R, am I right? And here we have two internal resistance, which is small R1 and small R2. Clear? Now what we are going to do, we are going to find what should be the value of the external resistance caps R. And for that they give the value. Actually this question has two subdivision. In the first question, we are going to find the value of R, caps R. And in the second question, we are going to calculate the power. Okay, so we just go one by one. So what we have to do, first of all, we have to see the value of the EMF. So what is the value of the EMF? Let's write what is given first. So the EMF of the first battery, which is epsilon 1, which is equal to 2 volt. Clear? And the EMF of the second battery, epsilon 2 or E2, which is equal to 3 volt, right? And the internal resistance, small r1 and r2, will carry the same value of 3 omega or 3 ohms. Clear? So that means the value of r1 and r2 has the value of 3 ohms. So now by using this value, we are going to find the value of caps R, that is our external resistance. So if you want to calculate the value of the R, here you have to use the voltage rule or loop rule. So Kirchhoff's voltage rule we studied in the theory. So if you want to apply the rule here, the most important thing, first of all, the circuit should be closed circuit. It should not be open. Am I right? So if you see the circuit diagram, it is perfectly a closed loop. So that means better I can make a sign here. So it is a closed loop. Now the most important thing, we must know what is the direction of the current, because they mentioned here we have the current. How much current is passing through the circuit? 1.5 milliampere, which is equal to 1.5 times of 10 to the power of minus 3 amp. Correct? So if you want to find the value of the resistance, external resistance R, we have to frame the equations. So how to frame the equation? Because in this circuit diagram, we have two EMF. That means we have two batteries. And in the theory, we studied the concept of single loop circuit and multi-loop circuits. Am I right? And sometimes the single loop circuits will have two EMF, like this circuit. So in such a case, what you have to do, you have to see the value of the batteries. That means we have to see the value of the EMF of the first battery as well as the second one. So we see the first battery. What is the value of this EMF 1? We have 2 volt, but if you see the second EMF, we have 3 volts. So which one is the strongest? The strongest is the second one. Am I right? So what we have to do, we have to consider the direction of the current is from the second battery. Clear? Clear? In such a way, you have to frame the equation. And what we studied in voltage rule? The voltage rule says you have to separate the EMF one side, and in another side you have to separate the current for the resistance. Am I right? The product of resistance and its respective current. So what we have to do, first of all, I am going to see the EMF. How many EMF we have? We have EMF 1 and EMF 2, but out of that, which one is the strongest one? The strongest one is the 3 volt EMF. So we have to consider the direction of the current, which is started from EMF 2. Clear? Now I have to frame the equation from the circuit. So please listen carefully. I am going to separate the EMF one side. So in this circuit, we have two EMF. Which one is the strongest? So I have to give the importance for that. So EM of 2, and here the EM of 1 will be in this direction. That means it carries the negative sign. Am I right? So EM of 1 we have to give as a main one because this is the strongest battery, 3 volt. So EM of 2 minus EM of 1, I separate one side, and in other side what we have to do, we have to write the product of resistance and its current. So how many resistance we have in this circuit diagram? We have 3 resistance, 2 are internal resistance, 1 is external resistance. So what we have to do, we are going to multiply this current, because when the current is flowing through this circuit in this direction, this current will enter this EM of 1. That means it will be passing through small r1, and also it will be passing through caps r, and also it will be passing through a small r2, right? So how I can write? We are going to write the product. So how to actually, here the product is nothing but the voltage drop, right? Because we studied Ohm's law, V which is equal to I multiplied by R. So that means if you see the current, when the current reach this resistance, it will have I multiplied by R1, because we have to write the product. And this I multiplied by R1 is nothing but the voltage, right? So likewise, if the current reach the second resistance, that means the external resistance, we have I multiplied by caps R. Likewise, this current will be entering this EMF, which is a product of I multiplied by small r2. That's it. So we are going to use this equation for finding the value of the external resistance caps R. Clear? So better I can rewrite this equation one more time here. So what is our equation? In the left hand side, I separate the EM of one side, and in the another side, I wrote the product of the current and its resistance. So that means I multiply by small r1 plus I multiply by caps R plus I multiply by small r2. So in this, I'm going to take the current as the common term. So therefore, I'm going to take I as outside of the bracket. So inside the bracket, what you will get? R1 plus caps R plus R2. What is in the left hand side? AM of 2 minus EM of 1. And now what I'm going to do, I'm going to move this I, that is current, to the left hand side of the denominator. By that, your equation will become EM of 2 minus EM of 1 over current, which is equal to R1 plus caps R plus R2. We are going to find the value of caps R. So what I'm going to do, I'm going to move this small R1 and R2 to the left hand side. By that, what will happen? The EM of 2 minus EM of 1 over I. When you move this R1 and R2 to the left hand side, each will takes the negative sign, right? So minus of small r1 minus of small r2, which is equal to caps R. Now you have to see the question. All the left hand side we have the data, right? That means what is the value of the EM of 1? 2 volt. The value of EM of 2 is 3 volt, and the current is 1.5 milliampere, and R1 and R2 takes the same value of 3 ohm, right? So I'm going to substitute the value here. So therefore, the external resistance R, which is equal to the EMF of the second battery, we have 3 volt minus 2 volt over 1.5 milliampere. So 1.5 multiplied by 10 to the power of minus 3 ampere minus 3 ohm minus 3 ohm, right? So now what I'm going to do, I'm going to find the value of R. So we just do one by one. So first of all, I'm going to calculate the 3 volt minus 2 volt, which is exactly 1 volt. 1 divided by 1.5 multiplied by 10 to the power of minus 3 minus 3 ohm minus 3 ohm, right? So what you'll get, 1 divided by 1.5 10 to the power of minus 3 minus 3 minus 3. I got the answer as 660. What's the answer for the external resistance? The external resistance value is 660.6 ohm, right? So I can write this value as 6.6 2.60 multiplied by 10 power 2 ohm. So this is the answer for the first question. Clear? Clear. And in the second question, what we are going to find? What is given in the second question? What is the rate at which thermal energy appears in R? So when the current is flowing through the circuit, you will get a thermal energy here. Am I right? So that means how much power. So when the current is flowing through the circuit, we are going to find what is the rate. The rate, the word rate comes means it is related to power. So that means in the second part of the question, we are going to calculate the power. Clear? But when you come for the power formula, we have three. Am I right? We have three different formulas. What are they? We studied power P, which is equal to I multiplied by EMF. And also we studied the formula power P, which is equal to current square I square multiplied by R. And also we have the formula power, which is equal to EMF square over R, right? So these three formulas we studied in the theory. But now the most important thing, which one is exactly applicable for this question? If you see this question, we have two batteries, am I right? So we can't use this. And also we can't use the last one. But if you see the middle one, we have the current and the resistance. So why we can't use the first one, the last one? Because if only one battery will be given, no problem. We can use the first one or the last one. But here we have two batteries. That's the reason it is really complicated. So that's that. For that reason, we are going to use the middle one. So for getting the answer for the second part, what I'm going to do, I'm going to use power P, which is equal to I square multiplied by R. As we already know, the value of the current is 1.5 milliampere. That means 1.5 multiplied by 10 to the power of minus 3, the whole square multiplied by the value of the R. So we already found the value of the R in the first part of the question, which is 6.60 multiplied by 10 power 2 plus 2, right? So I'm going to calculate the value of the power. So what's the answer? Let's see. 1.5 10 power minus 3 square multiplied by 6.6 10 to the power of plus 2. So the answer is 1.485 multiplied by 10 power minus 3. And what is the unit for the power? It is watt. So this is the answer for the second question. Clear? That's it.